Welcome to this lecture. My name is Mark Scythian. The date today is January 9th, 2023. This lecture is titled Quantum Mechanics Practical Applications. So if we were to equate Newton's second law of motion with Einstein's mass-energy equivalence and then found an equality between the mass components, we would then equate the speed of light to the square root of energy times acceleration divided into force. Now, if this equation was technologically achieved, then a physical particle would be free of quantum entanglement, or the electron particle known as matter would convert into electron wave known as light or energy. So matter would convert into light or energy, and then time and entropy decrease to zero in this speed of light state of a physical object. Let's say it is a spacecraft. So the occupants of such a spacecraft at the speed of light theoretically would not know their pure energy, but the observer would see light from matter. And so if this was technologically attained or achieved, access to 3 dimensions of time as well as 3 dimensions of space would be available, and then quantum superposition would then be a practicality in the quantum mechanical state. So all points in time and space, they possess a unique frequency, or frequencies per time and space vector. And so we have a magnitude and a direction. And suppose we had time to time and point to point in some direction and in some magnitude. So we will just assign that a frequency. So every point in time and space has a unique frequency. So a person could be sitting in the middle of the room as still as a statue, but at speeds below the speed of light, there is still displacement on the x-axis of time instead of the y-axis space. But every point in time and space have a unique frequency. So this is quantifiable through quantum computing, and if the quantification of a given point in time and space is understood and its frequency is deciphered, then at the speed of light it is theoretically possible to instantaneously match that point and travel through or displace time and space over 3 axes or 3 dimensions of time and 3 dimensions of space. So then we have the Schrodinger's equation and the Heisenberg uncertainty principle that theoretically prove or predicate, at the very least, the behavior of wave-particle duality of light. We also have the double slit experiment, and we understand that there is quantum entanglement of light energy, which then results in electron wave transfer as electron particle, i.e. a chemical element, a chemical compound, or matter itself. So then the Zeroth Law of thermodynamics, a practicality, would equate information with energy and energy with matter. So there's a conservation of information as well as energy and matter. And so at the speed of light, a physical object would then not experience the second law of thermodynamics, which is entropy, but more practically time itself. So the universe space is expanding faster than the speed of light. So the speed of light c can become useful to convert matter into energy, to access non-local superposition through quantum computing space-time frequency broadcast. So, one might ask, like, what frequency are you talking about? There is a vibrational frequency for every given point in time and space. So quantum computing's responsibility would be to quantify whatever that frequency is. And then at the speed of light, a solid object or matter itself, we'll say a matter itself, electron particles converted free of quantum entanglement, converting into electron waves, then theoretically would have access to any point in time and space. And there's multiple timelines, infinite timelines, infinite space timelines, put it appropriately. So therefore there's infinite frequencies for displacing time and displacing space instantly while at the speed of light. So it is a misnomer to say teleportation or time travel, but it is more accurately described as quantum superposition. So next we have the Lowrance factor. So what happens if V is equal to C squared divided by C squared is 1, and then 1 minus 1 becomes 0, and the square root of 0 is 0. So technically, at the speed of light, if matter reached the speed of light, technically its entropy in time would decrease to 0. So next we have gravity, which is the curvature of space-time. When a particle is moving slower than the speed of light over the functions of mass and radius. So we have planets, we have galaxies, we'll just call it celestial bodies. So their mass radius functions at below the speed of light is then inducing a curvature in time-space, which we know as gravity. And gravity is different at different points in the universe, but the mass stays constant. So force weight is mass times gravity. Gravity is an acceleration, and mass is the molar mass, the number of atoms and molecules, etc. So we're talking about counting the molar mass, particles, compounds, molecules, atoms, Avogadro's number, we'll put it that way. And then we have this curvature of space-time. So the mass will remain constant wherever you are in the universe below the speed of light, but its weight is going to change because it will have different gravitational accelerations depending on where in the known universe. So just imagine the James Webb telescope had a quantum computing system on it, and it was able to see farther, but see the radio telescopy to quantify the broadcast of certain peaks and valleys of frequencies that equate to like hydrogen or water or oxygen or nitrogen or carbon or whatever. And then a statistical graph or a curve is created to say that, okay, there's a likelihood this is life, there's a life form here. And then the interesting thing is, if this square root of E times A divided by F, that C combining both Newtonian and quantum mechanics together, if that was technologically achieved, however that's done, allowing a spacecraft to move at the speed of light, which is not very useful in space because space itself is expanding faster than the speed of light. But if that was possible, or that was achieved, or it has already been achieved and it's just not out yet, then the speed of light becomes so useful because that ship would no longer be matter, it would be energy in the form of light. And then it's open up the 3 dimensions of time as well as 3 dimensions of space, each having their own unique frequency, vibratory rate. And then the quantum computers could figure that out and then broadcast that frequency. And then we have that spooky action at a distance that Einstein talked about, where we reach parity between the electron wave functions of all electrons in the known universe. So we're talking about known universe. There's things we don't know. There's like everything, like most of the universe we don't know. I mean, if you have a 500 light year away galaxy and you were moving at the speed of light, on the Earth time plane, it would take 500 years of the observer on Earth to watch that light travel, that spaceship in the form of light travel. But the people on board would not experience the time. It would just be instantaneous. So now we're bordering into quantum psychology, perception, and all these other quantum-based scientific disciplines like quantum chemistry, quantum math, quantum physics, quantum biology, etc. And so it still is not practical because you'd like to tell your friends we're on this new galaxy 500 light years away and they're not around anymore because they're bound on Earth's time space gravitational field, and it's not at zero entropy, zero time, but the people on board the ship are. So at the speed of light, you have then another advantage, not at speed, but you have another advantage, and that is through quantum computing. If you could see at least the frequencies of a certain point in time and space through maybe the James Webb telescope, and then quantify the optical gradients into informational gradients, then it is theoretically possible that when you broadcast those frequencies for time and space, you would instantaneously quantum superposition to that place. So instead of having people on Earth wait 500 years for you to arrive in that galaxy, you would go there instantly. And then you would, so I mean, it would be like teleportation, but that's just too oversimplified a nomenclature, when it's really quantum superpositioning that is the practicality. And so we're not on one timeline, we're not on one space timeline, we are on infinite space timelines, and it's all predicated on our human consciousness, which is outside of time and space. And so we have the understanding that atoms are not solid, and that the atom or the electron wave particles, they're both double slit experiment, right? And they're rotating and revolving at the speed of light like electrical tornadoes. And this is then perceived as solidity or material or matter. And Einstein used to joke that, matter doesn't exist, time doesn't exist. Technically it doesn't, but the consciousness is not physical. It is we are the interface, we're like a device. The body and everything in the body are like device components, and then the consciousness can program those material states for better or for worse, depending on the perception, depending on the state of mind. And this is the quantum biology model. So your perceptions determine your physical biological response, right? So imagine we took advantage of C in a linear manner, and whoever's doing that, it could be SpaceX, it could be one of these space research corporations or agencies or whatever. But if it's known, if it's possible, if it's actually accomplished, and it's actually disclosed to the public that a spacecraft can reach the speed of light, then it has access to 3 dimensions of time and 3 dimensions of space. So in part 2, I'm going to cover matter management, self-replicating technologies. We also have the quantum biology, quantum math, quantum physics, quantum chemistry, and quantum computing applications to tie into the quantum mechanics practical applications. But with software and quantum computing based software systems, it is indeed possible to program the electron wave particles to match a certain chemical molecular compound in some certain state of programmability so that the matter itself can be programmed or made to self-replicate. And this is also programmable matter, and it falls under the concept of matter management. So thanks for watching part 1, and stay tuned for part 2.